Hello, my name is Leslie Roche, and I am a Cooperative Extension Specialist in Rangeland Science and Management at UC Davis. And today, I'm going to talk about some of the work we've been doing on public lands grazing and water quality. Public lands make up a significant part of California. Approximately 60% of California's rangelands are managed by federal, state, and local agencies. And these public lands provide critical forage sources for many ranches, which closely connects them to private lands management within individual ranching operations. Over the years, there have been concerns raised among the general public that microbial and nutrient pollution from grazing livestock on these public lands potentially degrades water quality, threatening human and ecological health. In the past 25 years, there's been a multitude of organizations, including the University of California, government and non-government organizations, as well as private landowners, who have come together and partnered to address issues on livestock grazing and human health across public lands. Recently, there's been quite a bit of focus on federal lands, which have a multiple use mandate to balance diverse resource use activities. And these federal lands can be a key component in the annual forage clock of many foothill and valley ranching operations in California. For example, many Sierran ranching operations depend on these high elevation rangelands during summer months when low elevation annual grasslands enter what is known as the inadequate dry forage period. During this time, the lower elevation annual grasslands forage quality is generally poor, and so managers must seek alternative feed sources, like the high elevation perennial grassland meadows that are available on public grazing allotments. And they do this to help to sustain livestock performance as well as the ranch. So with public lands decision making, there can potentially be broader ramifications for private lands management and conservation. The U.S. Forest Service manages about 500 grazed allotments in the state of California, which covers about 8 million acres and supports annually about 70,000 head of cattle per year. On top of this, the Forest Service also has an annual recreating population of about 26 million people, and so they also have the responsibility for safeguarding human and ecological health. And so California's national forests, for these reasons, have been at the crossroads of a growing debate about the compatibility of livestock grazing with other activities, such as recreation, that depend on the provisioning of clean and safe water. So to address this issue, the University of California and the Forest Service, along with multiple other collaborators, partnered to deploy the first comprehensive water quality survey of national forest public grazing lands, focusing on grazing land quality and grazing lands and water quality. And so we laid out three specific study objectives for this work. And the first was to quantify fecal indicator bacteria and nutrient concentrations in surface waters of these grazed lands. Our second objective was to compare these results to, first, the regulatory benchmarks that are in existence for the region, as well as recommended benchmarks for eutrophication or excessive nutrient enrichment potential concerns, and then finally, compare these to estimates of nutrient background concentrations. And then our third objective was to examine the relationships between water quality, environmental conditions, cattle grazing, and recreation across these grazing allotments. So basically, we asked, is public lands grazing degrading environmental quality and putting human health at risk? That's the main question. So in 2011, we initiated a public lands grazing and water quality study on 5 northern national forests across a broad range of environments and resource use areas. Working in coordination with the U.S. Forest Service and range and forest stakeholders, we identified a set of 155 sampling sites, which we monitored during the grazing and recreation period, which was approximately June through November of the 2011 sampling year. Sample sites spanned 3 resource use area types. And the first resource use area type were key grazing areas. And these are areas that were meadows and riparian zones that cattle were known to graze and occupy frequently throughout the grazing season. They tended to be areas of high forage quality and quantity, as well as had available drinking water for cattle. The second resource use area type were recreational areas, and these were developed and undeveloped campgrounds, swimming areas, and trailheads that were used by hikers and recreational horse riders. Lastly, we had sites that were established at perennial flow tributary confluences that had no concentrated use activities present, so that we could objectively include these comparison sites to the no grazing and recreation use areas. And so throughout the season, we monitored 155 sites monthly, and this totaled 743 water samples collected, in which we analyzed for a suite of water quality metrics, including indicator E. coli and fecal coliforms, and these are classes of fecal indicator bacteria, as well as we analyzed samples for indicators of potential excessive nutrient pollution. And so in terms of water quality benchmarks, there are a diversity of regulatory benchmarks currently in use across California. And this study area falls within the jurisdiction of 3 Water Quality Control Board regions. And so there are approximately 10 benchmark fecal indicator bacteria objectives under the combined Water Board, as well as US EPA recommendations that are applicable to the study area. And these fecal coliform, FC, and E. coli benchmarks here, these represent the range of those benchmarks that apply to the study region. And so we're going to walk through this table here to compare our study results here to the regulatory benchmarks, which is the range here, as well as the recommended maximum benchmarks for eutrophication or excessive nutrient pollution concerns. And so in the first set of benchmarks, which are the fecal coliforms here, fecal coliforms are basically, they're an older class of fecal indicator bacteria. And the US EPA, as well as the scientific community, are strongly recommending that states move off of this class of fecal indicator bacteria to more E. coli-based standards. But for the time being, and at the time of the study, these benchmarks are what has been in use across these different regions. And so if we look at the benchmarks here, the most restrictive fecal coliform standards at the time of the study were FC greater than 20 colony-forming units, or CFUs, per 100 milliliters of water sample. And you can see that under this most restrictive standard, we have a lot of exceedances across the board for all resource use area types, and just overall, we have at least 50% exceedances. This is particularly apparent when we compare it to the more commonly used fecal coliform standard of 200 CFUs, or colony-forming units, per 100 milliliters of sample, which we see a much fewer number of exceedances across the board. The second set of benchmarks are the E. coli-based standards, and while E. coli are not perfect indicators, they are the most relevant and contemporary benchmarks that are being recommended by the US EPA, as well as the broader scientific community. And with the E. coli benchmarks we see here, which represent the range of standards that are being used across this region, we are seeing much lower rates of exceedances across the board. So clearly, assessments of microbial water quality and resulting interpretations for risks to human health are dependent upon which types of fecal indicator bacteria benchmarks, whether they're fecal coliforms or E. coli, are being used to make those determinations. In terms of nutrients, we found that most overwhelming majority of samples were below laboratory detection levels, and most were at or below background estimates for natural nutrient levels in the region. And this makes sense because many studies have shown that montane and subalpine systems are generally nutrient limited, and they tend to be sinks for nutrients. So this result is not a surprise. Additionally, we also compared mean fecal indicator bacteria concentrations across the resource use areas. And what we found is, when we compare the key grazing areas to the comparison sites, or the no concentrated use activities, we found that there were no significant differences in fecal indicator bacteria concentrations between these key grazing areas and comparison sites. Additionally, for the recreational areas, we found the lowest and significantly lowest mean fecal indicator bacteria concentrations. And this is a good thing because this is where we would tend to find people, and this is where we would be concerned about potential threats to human health, where the potential exposure would be. But it's important to remember that all of these mean fecal indicator bacteria concentrations, both fecal coliform and E. coli, are still below those US EPA FIB-based benchmarks. But there are still some potential risk factors that we need to take into consideration. And so when conducting this study, we also recorded the environmental conditions and any resource use activities that may impact water quality at times of sample collection. And so we recorded conditions such as low stream flow, turbid water, whether cattle were presently grazing or not at the time of sampling or just present at the area, and whether there were people recreating in the area. And what we found was that fecal indicator bacteria concentrations were indeed significantly higher when stream flow was low or stagnant, when stream water was turbid, and when cattle were actively observed at sampling. But again, all but the most restrictive fecal indicator bacteria standards were met across all of these sites. So, in conclusions, what we found was that when we were looking at these water quality benchmark regulations, we found that all but the most out-of-date and restrictive fecal indicator bacteria water quality benchmarks were broadly met across sites. Throughout the study period, in fact, US EPA recommended E. coli benchmarks were met for over 90% of samples and over 83% of sites. That means that the overwhelming majority of sites did not have a single exceedance throughout the entire sampling season. We also found that observed nutrient concentrations were at least an order of magnitude below levels of ecological concern and generally were similar to background estimates. So in terms of management, under modern public lands grazing management practices, and that is practices that meet the modern standards and guides for federal public lands planning and policies, cattle grazing, recreation, and provisioning of clean water can be compatible goals. And so we just need to work with that capacity of rangelands, which they have to attenuate pollutants, and work with the potential to manage for any risks or exposures.
You can find more informative presentations covering ranch water quality topics on the UC Rangelands website, and look for the Water Quality Information Hub or direct your web browser to the URL shown on this slide.